Hello everyone. Today we shall know the formation of partial differential equations. Before that, we shall know the definition of partial differential equation. A differential equation involving partial derivatives with respect to more than one independent variable is called a partial differential equation. Now we'll form the partial differential equation. It involves two methods. One is by eliminating arbitrary constant and the second one is by eliminating the arbitrary functions. In this chapter, we shall denote z, we shall consider z as a dependent variable and x and y are independent variables, and differentiation of z partially with respect to x is denoted by dou z by dou x, that is nothing but p, small p. Again, differentiation of z partially with respect to y, that is denoted by capital small q. Again, the differentiation of dou z by dou x again with respect to x, partially with respect to x, that is denoted by small r. Similarly, differentiation of dou z by dou x partially with respect to y, that is mixed partial derivative, that is by small s. And again, dou square z by dou y square is represented by small t. We shall form the partial differential equation by eliminating arbitrary constant. We shall know this method by considering an example. Here, the question: eliminate the arbitrary constants a and b from the equation z equal to x minus a whole square plus y minus b whole square and form the partial differential equation. That is, we will form the partial differential equation by eliminating the arbitrary constants a and b. So we shall consider the given equation as 1. Now differentiate equation 1 partially with respect to x, that is dou z by dou x. We are going to represent it by small p. Differentiation of x minus a whole square partially with respect to x gives 2x minus a. Since we are differentiating with respect to x, here y acts as a constant, therefore differentiation of this term will be equal to 0. So you will left with dou z by dou x rp, this is equal to 2 into x minus a. That is, from this equation you can write x minus a as p by 2. Call it as equation 2. Again, differentiate equation 1 partially with respect to y, that is dou z by dou y, that is nothing but q. Again, differentiation of equation 1 partially with respect to y, that means we'll treat x as constant. We know differentiation of a constant is 0, therefore you will just left with 2 into y minus b. That implies y minus b after cross multiplication, that is nothing but q by 2, call it as equation 3. Now substitute equation 2 and 3 in equation 1 so that the arbitrary constants a and b will be eliminated. Look here, x minus a is replaced by p by 2. Again, y minus b is replaced by q by 2. So that is p by 2 whole square plus q by 2 whole square. So here this is the required partial differential equation. Observe here there are no arbitrary constant. So this is the partial differential equation.